we are going to do polynomials, linear factors, and zeros. So in problem number 1, we are going to factor this polynomial. Here's our steps. Our first step, if possible, we're going to find a greatest common factor. And then we're going to factor it, or you can call it unfoiling. So find the greatest common factor. I look at x cubed, I look at x squared, I look at x. They all have x in common. So I'm going to divide them all by x. X comes out of all of those. So when I have x cubed divided by x, 3 minus 1, that's how I got x squared. And then x squared divided by x, that's how I got x. So I got minus 2x. These x's cancel each other out. So I have minus 15. So next thing I want to do, I'm going to factor this. 2 factors multiply to negative 15 and add to negative 2. So 3 and 5 multiply to negative 15. And they add to positive 3. So to see if this is correct, I'm going to check the middle. So I'm going to go 3 times x is 3x. Negative 5 times x, negative 5x. And I'm going to add them. 3x plus negative 5x is negative 2x. So it is factored correctly. In problem number 2, it's already factored for us. We're going to find the zeros of the polynomial function, and then we're going to make the graph. So I want to figure out my degree. I have x times x times x is x to what power? 3. My degree is 3. So my end behavior, my degree is odd. The ends have to be in opposite directions. So it is going to start down, and it ends up. So I want to find my zeros of this polynomial function. So I'm going to look, x plus 2, what makes that 0? Negative 2. Nice. X minus 1, what makes it 0? 1. X minus, 3. And because this is the third degree, it's going to have this end shape to it. So I have negative 2, so I put a dot right here at negative 2. If I have x equals 1, I put a dot right here. It's 1. X equals 3, dot right here. So then I'm going to make it, I'm going to start down, and go through those 3 points, and it makes the letter N. So I'm going to go x times x times x. So what degree do I get? 3. So where does it start? It ends up. Because it's an odd degree, they have to go in opposite directions. Even degrees have to go in the same directions. So my first one, just x by itself, what makes it 0? 0. Because if I have x by itself, I just get 0. And that's hard. A lot of kids miss that. If I have x minus 3, what makes it 0? 3. What's the next one? Negative 5, because negative 5 plus 5 is 0. So it's going to make this N shape. It's going to start down and end up. So I have negative 5 right here. I have 3 right here. I have 0 here. So then I just make it, I just sketch it. Negative 5 makes it 0. That would be that blue dot. So in problem number 3, we're going to write a polynomial function from its zeros. So they give us the zeros are negative 2, 2, and 3. So if negative 2 is a 0, that means the first binomial is x plus 2, because negative 2 plus 2 is 0. The next one is 2. That means I have to have x minus 2, because 2 minus 2 is 0. My last one is 3, so it's got to be x minus 3. So I'm going to multiply these out. So I'm going to multiply my first 2. I'm going to go x times x is x squared. And then I'm going to do my outer, x times negative 2. Negative 2x. I'm going to do my inner, 2 times x is 2x. I'm going to do my last term, 2 times negative 2 is 4. Negative. But you notice these two are conjugates of each other, there's no middle term. I could have done that right away and saved a bunch of time and got x squared minus 4. So I am going to multiply, do the same thing, and do FOIL. I'm going to go x squared times x is x cubed. I'm going to do my outer, x squared times negative 3x squared. My inner, negative 4 times x minus 4x. I'll do my last term, I got 12. So in problem B, we have 4 zeros. So it's 4 degrees. So negative 2 makes it 0, so it's got to be x plus 2. 2 makes it 0, x minus 2. 2 again, x minus 2. 3, x minus 3. So I have the problem set up.